We're going to do a lot of measurements with these multimeters. And before we even start, most important thing is to make sure that we put the leads into the right sockets down here. The black one should go in the common, and the red one should go into the voltage, ohms, and so on measurement to let us make some measurements. Now, if we have this dial, we can set it to a variety of different locations. And I'm setting it down here to the continuity test. I'm going to turn the power on. And when I touch the leads together, I get a little clicking sound, and the indicated number goes from 1 down to a very small value, indicating I've actually got a connection there. And when I separate them, it shows that I don't. So one of the things I can do, for example, is if I plug them into the board here, into two locations that are connected, it tells me they're connected. That's useful for checking your connections. The next thing we might want to do is measure resistance. We'll want to measure resistance on a resistor or a component that's isolated from the rest of the circuit. And we can pick one of these resistance measurement ranges here in the ohms section. If I touch the leads to both sides of this resistor, what do I get? I get about 0.5 kiloohms. It's got a K up there at the end of the display. Now let's have a look. I was on the 200K measurement range. Now if I'm only measuring less than 1K resistance, then I might want to go down to the 2K measurement range, and I'll measure again. And this time I get a much more detailed result. I get about 455 K ohms, or 455 ohms. If I hold that between my fingers like this, I still get very close to the same resistance value. So as long as I'm not measuring really high resistances, the resistance of my body doesn't really show up as much at all. Now, it's important that we pick the right scale. If I went to the 20 megohm range and measured, I really don't see much. It tells me that the resistance is basically 0, because the resistance of this little resistor is so small compared to the megohm range that I get nothing from that. So we can measure resistance. We can also measure DC voltage. Now right now I've got it set on the 2 volt range. If I plug the black lead into ground and plug the red lead into the red side there, I get this indication saying I'm up past the measurable voltage range. So if I switch up to 20, I find that the voltage on my Arduino is about 4.93 volts. If I go and measure the output from my potentiometer here, I've got 3.5 volts, and I can change that back and forth. If I go down to a lower voltage, say down around 1.8 volts, and switch to the 2 volt range, I get more significant figures here, which is indicative of the fact that I'm also getting a more accurate measurement. So always go to the smallest range that you can while still being able to measure the voltage or the resistance that you're trying to measure.